So right now you're probably thinking, what the heck was that? Well, that was the sound coming out of my customer's speakers in her home where she has this IM5000 installed. This unit was installed when the house was built in the early 90s, and the current owner has been in the house for about 5 years, and the system was disconnected when they bought the house, and the previous owner told them that it didn't work. That's why it was disconnected. And it was just recently, like a week ago, that she contacted me to find out about getting it repaired so it'll all work again. And when I went out to her house and hooked it back up, that was the sound that was coming out of her speakers all throughout the house. Pretty annoying. So now I've got it here at the shop, and right now I have it hooked up to power and a single speaker. It's one of my test speakers that I know is good, and I'm going to go ahead and power it up and let's see what we get. And that's enough of that. You may have noticed if you watched carefully, or you can go back and watch it again, that when it was powered up, the display was completely dark and blank, no information. This set is really sick, or in technical terms is what we would refer to as broken. So now I'm going to see if I'm going to be able to fix it or not. This may be one of the most broken 5006s I've ever seen. So it'll be interesting to see what actually happened to it. If I find something interesting as I go along, I'll update this video. Otherwise, the next time you see it, it should be working. So stay tuned and let's see how it turns out. That's all. Back in a bit. Okay, as promised, I said if I found something interesting, I would come back and show you. So I've taken the main board out of the master station, and when I flipped it over, this is what I found. So what we have here is this right here used to be C186, which is a 0.22 microfarad capacitor. It's a little surface mount capacitor like this one. It's about the size of a grain of rice, and it's totally melted and it burned or exploded, and you can see the pattern of the failure as it sort of cascades down across the board. So it actually probably flamed and burnt, and this is the residue from that, like this. So this is totally gone. The traces here and here and here and maybe over here too, it's hard to tell till I clean it off, are totally burnt away, and this is why the board's dead. So I looked on the schematic, and it turns out that of the two AC power lines that come in from the low voltage transformers, this is the very first component in the series off of J17, which is one of the two transformer connections on this side of the board. There are two capacitors like this. They're mounted in series, and this one's basically had the ass blown out of it. So we have to repair this damage and see what else may be wrong on the board. Why did this happen? Don't know exactly. My guess is they may have had a power surge or something like that, and it took out this component. I don't think it was caused by some other failure further down the circuit. I think it started here. So that's what I found. Now let's see if we can get it fixed. Okay, so I just thought I'd show you. I've gotten all of the residue cleaned off the board, and you can see right here, it's actually still labeled C186 right here, and the capacitor flamed up, and although it's probably kind of hard to see on the video, it's actually burnt the board. It's burnt down below the surface of the board, so we have kind of a crater right here, which is not good. But there's enough of the traces left that this shouldn't be too difficult to fix. The way this is supposed to be connected is this trace comes up and goes over, and there would be a pad here, and then it continues on this side, and then this trace comes up, jogs up, there's a pad there, that's still pretty much intact, so it's not too bad. Then it continues off on this way. So what I'm going to do temporarily is I'm going to sort of stitch this back together, because what I want to do is replace the blown up capacitor and put the circuit back together so I can do other testing on the board before we get into a full-blown rebuild. I want to see what else might be wrong with it. So I'm going to stitch the broken trace back together and temporarily solder a capacitor in place just to complete the circuit. What I've done here, you can see how these areas are shiny. That's copper, it's a copper trace. I've scraped off the solder mask which covers the copper, and what I'll do is put a little flux and flow this all with solder when I stitch it back together. Not only will that help reinforce the trace temporarily, but the added solder will increase the current handling, so if there's any degradation of the copper traces themselves from the explosion, that'll make up for that for the time being. So I'm going to put that back together, hook this back up, and do some voltage measurements and see where we are. Okay, so I've stitched the board back together, and I hooked it up to the power transformers, and I did some quick initial voltage measurements on the two power supply sections, and it seems as if all the voltage regulators and all that are fine. So I decided before I went any further, I put it back in the set, put it all back together, hook it back up to our test speaker, and let's see where we are with it now compared to where we were with it before. So I've got a same setup as before, one speaker, the antenna, two transformers. Let's power it up and see what we get. And you'll see that we still have the loud noise. However, the display is lit up. We can actually turn the radio on. We turn this down. Turn that down. It sounds like a tweeting bird. Alright, so let's tune our tuner here. We have a tweeting bird here also. However, if we scan, it doesn't seem as if it's going to stop. However, we can do this. We can do door call. Door communication works even though we have the tweeting bird. Oh, now it's really angry. And it's going to settle down. Watch, it's going to disappear. Oh, maybe not. Anyway, we'll do all call. And we can also do select call. And it connects. Alright, enough of that. Okay, so what does all this tell us? Well, it tells us that it's not broken anymore, but it's really, really sick. So I'm not sure why the capacitor blew up and fried and cooked the board. It probably was a power surge in my guess. And once that was repaired, we're now back to a fairly standard problem on 5006s, which I've done other videos on. So even though it doesn't work correctly, it does work, and all the functions seem to work, at least as far as you can tell at this point. So now I'm going to rebuild the board, and I think when I put it all back together the next time, it'll be good to go. So more in a little bit. Alright, there we have it. There's nothing like a little Van Halen 1984 to listen to when you've finished up a good repair. So the 5006 has been rebuilt, and even though it started off with a fairly dramatic blown up component, smoke the board kind of damage, after the damage was repaired, it really turned out to be simply an ordinary rebuild. So whatever happened to it was interesting, but in the end it didn't really require a lot more additional work than a regular 5006 rebuild. I just thought I'd show you. You never know what we're going to find. That's all for this video. I hope you found this interesting, and if you did, please give it a big thumbs up on our YouTube channel. If you would subscribe to our YouTube channel, it helps raise our search rankings so more people will find our videos. If you have questions or comments, please leave them in the comments down below at the bottom of the video, and I'll answer all the questions or comments that I get. And that's all for today. See you on the next video.